Project NOMAD is a self-contained offline survival server built to preserve human knowledge and education when the internet is not available. It runs from a machine on your network and opens in a browser, giving people local access to reference libraries, maps, learning material, notes, data tools, and AI assistance when connectivity is unreliable or gone. Most self-hosted projects solve one narrow problem. NOMAD is built as a control surface for several local services at once. The command center is the front door. Behind it are containerized tools for reference material, learning content, maps, files, and AI. In practice, it behaves more like a small offline operating environment than a single application. This is useful for a few different groups. Emergency preparedness builders get offline references and maps. Classrooms, community centers, and field teams get a local education and knowledge box. Home lab users get a concrete orchestration project. Developers get an example of packaging many open-source services behind one operator interface. The repo has real community gravity. GitHub shows 25.2 thousand stars, 2.5 thousand forks, 493 commits, 61 releases, and an Apache 2.0 license. The codebase is mostly TypeScript, with shell scripts around installation and orchestration. This is an active project with enough usage to reveal real operational issues. The setup path is direct. Start with a Debian-based machine, run the terminal install script, and then open the local browser interface at port 8080. The repo describes NOMAD as a management UI and API for containerized tools. That is the core design. One local control surface manages the offline environment. Each bundled service has a specific job. Kiwix handles reference libraries, Calibri brings structured courses, Protomaps provides downloadable maps, CyberChef gives local data inspection tools, Flatnotes covers simple notes. Ollama and Qdrant support local AI and document retrieval. Together, they cover the basic tasks people still need when connectivity is unreliable. The command center keeps the system usable. Instead of remembering every container, port, and config file, you use the dashboard. It exposes the education platform, knowledge base, docs, maps, settings, app installation, and guided setup from one place. The offline library is one of the most practical parts of the project. Kiwix lets the server carry zim files for Wikipedia-style references, medical material, manuals, ebooks, or deployment-specific collections. Recent releases focus on download reliability, staged files, corrupt archive handling, and content browsing. Those details matter when large files may be downloaded over weak connections. The AI assistant turns the server into more than an archive. Ollama can run models locally. Qdrant stores embeddings. Uploaded documents can become searchable context for retrieval-augmented chat. Recent releases also support remote OpenAI-compatible hosts, so a smaller field machine can use a stronger model server when one is available. Setup is intentionally direct. Update apt, install curl, download the install script from GitHub, run it with sudo, then open the command center in a browser. The advanced path is Docker Compose. The quick path is for users who want the server assembled without wiring every service by hand. The hardware requirements split into two tiers. The management app itself is light, a dual-core CPU, 4 gigs of RAM, 5 gigs of disk, and a Debian-based OS. Local language models and a large offline library need more. The recommended target is 32 gigs of RAM, a real GPU, and at least 250 gigs of storage. The first use path matters because an empty offline server is not useful yet. The easy setup wizard points users toward curated content collections. The benchmark tool gives builds a way to compare hardware capability. Those details make the system easier to operate after installation. The privacy model is simple. NOMAD needs the internet during installation and when you download new content. After that, normal operation is designed to stay local. The README says there is no built-in telemetry, and the latest 1.31.1 release added configuration to disable anonymous telemetry in the Qdrant container for new installs. The main security trade-off is access control. NOMAD currently ships open on the local network with no authentication layer. That can work for a trusted offline box, but it changes deployment. If other devices can reach it, exposure needs to be managed with network-level controls. The maintainers explicitly warn against exposing it directly to the public internet. Version 1.31.1 shipped on April 21, 2026. The release is mostly operational hardening, cancelable AI model downloads, better ZIM embedding, atomic file download staging, corrupt file handling, SSRF fixes around map downloads, sanitized backend errors, and dependency security updates. That kind of maintenance matters for a server that manages local tools and large offline content. The limits are clear. You need supported Linux hardware. You need storage for the content you actually want. Local AI still depends on memory and compute. Because the system can manage containers, the host should be treated like infrastructure. This is a practical offline server, not a zero-maintenance appliance. NOMAD is compelling because it is practical. It does not reduce offline access to one chatbot or one download folder. It gives you a local command center for knowledge, tools, and services that you can inspect, operate, and extend. For more GitHub repo deep dive videos, subscribe to Build Things with AI.